Hello everyone. So this is a contest discussion video of Codechef Starters 164 contest. So we are gonna discuss here five problems A, B, C, D, E from DIV 3. Okay, so let's take the first problem. Let's discuss the first problem. So in the question, you are given two people, okay, like Ved and Varun, and you are also given n chairs, and those chairs can be stacked on each other, like they can keep above each other. Okay, and now you are also given the height of Ved and height of Varun, and basically if you read the whole question you will get to know that in this you have to find that uh, whose height is more. Okay, Ved or Varun, like, but there is a condition, like at the start, like the security officer uh, gives all chairs to Varun, okay, except one, which is the tallest chair, and he gives that to Ved. Okay, so basically Ved has one chair and Varun has all other chairs, but the chair which Ved has is the highest, like which is tallest. And Varun, what can Varun do? Varun can stack all those chairs above each other, and yeah, he can stand up on that chair, and Ved can just stand up on the highest chair. And yes, so you have to then like calculate the height, like you are also given Varun's and Ved's height, so who can see more clearly, or yeah, more clearly you have to result in that if the heights of both Ved and Varun are equal, then you have to print equal. If height of Ved is greater, print Ved. If Varun is greater, then print Varun. Okay, so let's take an example here, like let's take this one, test case 3. Okay, so uh, test case 3. So in the input format you have T and K and P and number of chairs. So like let's take the example test case 2. So here n is 6, K is 10, and P is 6. So what is K and P? So K is Ved side and P is Varun side. So Ved side is 10, and Ved will get the highest chair. So here the highest chair is 7. So Ved's total height will yeah, it's 8. Ved's total height will be 18. 10 plus 8, 18. And what will be the Varun side? It will be 6 plus 6 plus 1 plus 4 plus 5 plus 10, which will be greater than 18. Therefore we will print here Varun. So yeah, we got the answer for second Varun. So let's, like, what's the code? Let's see that. So I have taken the input first. Okay, then I have sorted the array. Okay, why I have sorted? I have to just like easily calculate the highest amount of chair available. And what I do, I just plus the highest amount of chair in the Ved side. Okay, now Varun side is P currently, and I will plus all the remaining chairs from n minus 2 to 0 to in the Varun side. If they are equal, just print equal. If Varun is greater, print Varun. If Ved is greater, print Ved. Okay, so this was the solution for the first question. Okay, let's submit it. Yeah, it's getting accepted. Now let's see the second question. Okay, so the second question was swap and flip. So in the question you were given a binary string s, okay, which was of length n. Okay, and you can perform these operations on the string, and now you have to return, like, whether in the yes or no, whether you can transform that string to the another given string t or not. So what are the operation you can perform is just swap the elements of the uh, string characters of the string, which is 0 or 1. And the second operation you can do is just flip the bit. Okay, uh, like you have to pick, and you can't like flip only one bit, you have to pick two bits. Okay, and then flip both. Okay, so you have to do this in the question. So you have to know, tell, like, you can or you can't. So now see, like let's take the fourth test case. Okay, so it's clear that first we will count like number of bits in this. Okay, and number of set bits in this, and number of set bits in here. So like if we can count, and we will get one set bit here, and we will get three set bit here. Now we want to transfer we would like to transform s to t. Okay, so what we will do is the first operation which is given, that we will use for like ordering the elements. Like if we can swap any element, then obviously we know that we can, like, if there are equal numbers of 1 and 0 in a string, in both the string, then we can order it by swapping anything, like swapping in any way, and we will get the string equal. Okay, like yes, if we will get the equal, like if there in this string there would be three ones, and we are also having three ones here, then we can do any swappings here and in any order, and we will definitely get this 11101. But now the point is that you are not having equal number of ones here. Okay, but then also you can make it equal, both the string. How you can do that? Because see, the difference between the number of ones in this is even actually. Okay, so what does that mean? That if the difference is even, that means you can convert those two one. Okay, the which are not one, like here difference is 3, no, difference is 2, so you can pick two zeros. Okay, and you can flip their bit equal to 1. But if there would be in this, if the difference would be only 1, like in this example the difference is only 1, so you cannot flip single bit. Okay, you have to take two characters, and you have to flip both the characters. Okay, so if you want to flip both the characters, you want even thing now, like if like if you will like you have in this, you will pick these two characters. Okay, and you will flip those, then you will again get 1 1. Okay, and now again the difference is only 1 of 1. So if you have odd difference, okay, so simply the answer will be no, because you can't perform this operation and uh, make the number of ones equal or number of bits equal. Okay, but if you have even, then you can do that. And if you have done the if you do just the number of bits equal of 1 and 0 in the both the string, you can just use the first operation and swap those bits, and you can make the both the strings equal. Okay, now what's the code for this? So I there can be many ways to do that. What I have done is just I have taken z and z1 variable to count the number of zeros in the strings. Okay, so we can do for 0 also, we can do for 1 also. Okay, what I have done is I have just count the number of zeros in s, count the number of zeros in 1. Now if z1 is equal to 0, z, or the absolute value, like the difference is even, then print s, else print no. Okay, so this is the solution for this question. Let's try to submit this. Yeah, it's getting correct answer. Okay, now let's see the next question, Halloween array. Okay, so Halloween array, yeah. So in the next question, Halloween array, okay, you are given an array. Okay, okay, you are given an array. Okay, and then what you have to do is, in this you are given an array of n integers, and you are also given a range l and r. Okay, so here you have to calculate something. Okay, and then you have to like tell uh, in the yes or no that whether that thing is between l and r. If it is between l and r inclusive, then print yes. If it is not, just print n. So what you have to calculate here is, you have to do pairwise XOR of all elements. Okay, and you have to multiply them. Now that thing is, if less, like if in the range l and r, just print yes, else no. So what does pairwise XOR and multiplication of all that means? Like if you have here like 2 3 4. Okay, what's the input? You are given nl and nl and r and the size of array. Okay, yeah. So yes, here if the size, not size of array, the elements of the array. So like n is 2, l is 3, and r is 4. Okay, so you are given two elements. Now pair by there can be only one pair formed in this question. Okay, 1 and 3, 1 comma 3, the XOR of 1 comma 3. But let's say we have a test case like this: 1, 2, and 3. So how much pairs can be formed? Like first pair will be 1 comma 2. Okay, then the second pair will be 1 comma 3. Okay, then the third pair will be yeah, 2 comma 3. So these many pairs can be formed. Okay, so likewise it will increase. So increase, so basically like if there are n elements, n minus 1, n into wait, n into n minus 1 divided by 2, these many pairs will get formed. Okay, around these many pairs. Okay, pairs. Okay, so like yeah, you have to form all those pairs, do XOR of them, and then multiply them. Okay, and you have to then tell is it is lying in the range or not. Okay, so the observation in this is like, uh, if what if like if the elements are repeated in the array. Okay, if the elements are repeated in the array, so we know the concept, like if we XOR like two elements, okay, which are same, then we will get zero. Okay, this happens in case of XOR. If you like XOR the two elements which are same, then you get zero. So now definitely if there is repeated elements in the array, so there will be a pair formed of those repeated elements, and if that would be zero, then they will do the multiplication zero now, because at the end you have to multiply all the pairs multiplication, resultant XOR of pairs, you have to multiply all them. So if one of the result of pair is zero, then all the whole multiplication will be zero. So for that we can just check like, here that we can sort the array and just check like, we have taken boolean flag variable that check if that there is present repeated element present or not. So if it is present, just break and make the flag true. So now if flag is true and zero, because the answer for this case will be zero, so if zero is in the range L and R, just print yes and continue. Continue. Okay, but yeah, if else the flag is not true. Okay, yeah, sorry, if flag is true and zero is not in the range of L and R, then you have to print no. Okay, so this was one of the case. Okay, now second case is like, uh, you can observe here like if the minimum how much XOR can be formed of like two elements. It can be formed like, uh, how much, one. Okay, minimum it can be formed. If it's not forming zero, then obviously XOR of a pair can be formed one. But there is a property of XOR if all elements are unique. Okay, we know now all the elements are unique, all elements unique. Okay, okay, and let's suppose the array is 1 2 3 4 5. Now let's suppose that if you do XOR of 1 comma 2, okay, you get 1. Okay, now if you got 1, now it is not possible in any case that if you will do 1 comma 3, you will also get 1. And you if you will got you will do 1 comma 4, you will also get 1, because the property is like, if you do A XOR B, then you will get C. So this B is always unique. Okay, so like there can be not multiple B's. Okay, so by this we can conclude that we will get only one time one. Okay, and then we will get all the elements greater than one. So let's suppose we get all the elements 2. Obviously we will not get 2, because now only I have told you the property. So let's suppose we at least get 2, at least we will get 2 now. So if we will get 2, and the how much pairs will be formed? Pairs will be like, if n is 10, so how much pairs will be formed? It will be like, uh, n into n minus 1. How much it is? 10, uh, 10 9. How much it is? Yeah, it is 45. Okay, 10 into 9 divided by 2, it is 45. So okay, so how much times you are multiplying 2? You are doing 2 to the power 45. Okay, so these many times you are doing. But we know that the range, how much range we are given, like the R can be in the range 10 raised to 9 only. So the answer for this minimum answer would be greater than 245 or equal to 245. Obviously not equal to, greater than 245. So for that case, if n is greater than n, always the answer will be no, no. Yes, so this was the observation for this. Okay, I've written this here also. So if n is greater than 10, you have to just print no, because the answer will be always no, because the answer will go beyond 10 raised to 9, and r cannot be beyond 10 raised to 9. So answer will be no. Now what is the rest case? It is all n is less than equal to 10. So for that you can do brute force. You can just calculate XOR of all pairs, and that will be obviously in less than like n squared you can do, because n is now only less than 10. So yes, if answer is, you do here the XOR, and just multiply it. Like in this step you are drawing every pair and then multiplying it to the answer total variable. And if it is less than equal to, if it is in the range of yes, just print yes. Okay, if it is in the range L and R, just print yes. If it is not, just print no. Yes, so this was the solution for this. Let's submit it. Okay, yeah, it's getting accepted. Okay, now let's see the next question, which is we have seen A, B, like simple swap and flip A, simple one, and then swap and flip B. Then we have seen C, Halloween array. Now let's move on to D. Okay, so in the question you are given an integer n. Yeah, that's all you have given, and you have to print like you have to construct a permutation. Okay, in which any subarray from that array should not be divisible by n plus 1. Okay, so you have to form that permutation array, that you have to form the array in that way that any subarray from that array should not be divisible, like sum of any subarray should not be divisible by n plus 1. Okay, if it is possible, print the array. If it is not, print minus 1. Okay, so yeah, like let's take an example. Like if for n is equal to 3, you can see that uh, if we sum anything, like the n plus 1 is 4. Okay, now 1 plus 2 is not divisible by 4, 1 is not divisible by 4, 2 is not divisible by 4. Okay, now 3 is also not divisible by 4, and if you sum all these things, so 1 plus 2, 3 is 3 plus 3, yeah, 6, 6 is also not divisible by 4. So any subarray sum is not divisible by 4, which is n plus 1. So yeah, we print the array. But for the case of 2, 1 comma 2, n plus 1 is 3, and like if we take the whole array, and that is one subarray, and that is the sum of that is 3, and that is divisible by n plus 1, so we just print minus 1 in that case. Okay, so yes, so important observation in this question was like uh, how much can be the maximum sum, okay, of that subarray if we take whole subarray. Okay, and what is that? It will become n into n plus 1 by 2, because we have to like construct a permutation. Obviously the numbers will be from 1 to n, so the sum will be n into n plus 1 divided by 2. Now if n is even, okay, so this 2 will divide that n, okay, obviously because it is even, and we will remain we will get something x into n plus 1. Now obviously that is divisible by n plus 1, because if we divide it, then we will get x. So yeah, for if the n is even, obviously the answer will be minus 1 only, because the whole subarray sum, like the whole array sum will be divisible by n plus 1. So yeah, like we can see in the fourth test case, 4 and 2, the answer for it is always minus 1, because like if we take 1 2 3 4 also, 1 2 3 4, for n is equal to 4. Now you will sum it, what it is. 4 plus 3 is 7, 7 plus 2 9, 9 plus 1 10. Okay, now 10 is divisible by 5, 5 is n plus 1. Yeah, so it is not possible for that case. Okay, now like in the else case, which is odd. Okay, so uh, another important observation is like for the answer to be present, there should be all the unique prefix sum mod n plus 1. What do I mean by this is, like if you take an array, like if you form, you're able to form an array. Okay, now in that array, the mod, like the prefix sum of it should prefix sum mod n plus 1 should not be equals. Okay, like what if it will be equal? Let's see. If let's say you have an array, let's take it is 1 2 3 and 4. Okay, now you just do the prefix sum mod n plus 1. N plus 1 is 5. Okay, so first index it will be prefix sum, prefix sum. No, so at first index it will be 1. Okay, now at the second, 1 plus 2 mod 5, it is 3. Then 3 plus 3 mod 5, it is 1. And yeah, 3 plus 3 mod 5, 3 plus 3 6, 6 modulo 5, it is 1. And 1 plus 4, yeah, it is 0. 1 plus 4 5, 5 modulo 5 0. Now you can see the elements are repeating 1, okay, and 1. Now what does this mean? That till here we were getting the same remainder. and till here also we are getting the same remainder. That means this array will be divisible by 5, and we can see here like 2 plus 3 it is divisible by 5. So if the prefix sum mod n plus 1 array will contain any duplicates, or it will contain 0, okay, then what will happen, that will be divisible by 5. Why it is 0, why 0 case is there? Because see, if the sum will be, the remainder will be 0, that means that from prefix sum till here, uh, mod n plus 1 will be divisible by 4 5, divisible by n plus 1. So like 4 plus 3, which is 10. So we know that the prefix sum is 10 here till now, and we are getting remainder 0 as it is divisible by 5. Yes. So yeah, there should be no similar elements present in that array. If it is present, then the permutation is not correct. So to make such prefix like such uh, prefix sum array mod n plus 1, you have to place elements likewise, that the elements in the prefix sum array mod n plus 1 should not be like they should not contain duplicate or any 0. So for that, what you can do, just print the numbers in even odd fashion. Okay, even odd fashion. So like j is here for even, okay, and I is here for odd, and here I have written the code for like just print it in even odd fashion. And yeah, at last in next line, let's try to yeah, submit it. It's getting accepted. So okay, now let's see the last question. It was the fifth question, connecting wells. So this was the graph question. Okay, so in this what you have given is like you are given coordinates, okay, on a plane. Okay, and what does that coordinates specify? So coordinates specify the like it there is a well on that position. Okay, okay, so there is a well like at every coordinate. You are given coordinates and there is a well on that coordinate. Okay, now in the village what they are doing is they want to connect all the wells. So for that they have like done something, and at every second uh, the well which is like at coordinate like let's suppose the well is at 1 comma 2. Okay, so now the well having a channel. Okay, four channels a particular well is having. Okay, and four channel, and every channel, every 1 second, 1 second, channel expanding in north, south, west and east direction. Okay, so every second it is expanding. Okay, yeah, expanding. There are m channels for each well, and at time 0 all channels have 0 length. Yeah, and yes, every second channels extend 1 unit. Yeah, every second 1 unit they are expanding. Okay, in the north, east, south and west directions. Now like two wells, like if there is 1 comma 2 one well and 5 comma 7 one well, then they will be connected. Okay, if their channels overlap or touch each other. Okay, so yeah, if they will be connected. Now you have to tell the minimum amount in which all the wells are connected. Okay, so obviously now you can think like this is a graph problem, and the edge is like channels. Okay, channels. Okay, so like if we think like brute force. Okay, so we are given n wells, we will connect all the wells now with their like, because every well can be connected to every other well. Okay, somehow it can be connected, like it will take much time, but yeah, it will be connected. Okay, so we will connect all the wells with every n well with every and other n minus one well, every other n wells. Okay, so let's see what will be the edge weight. Okay, now let's take this 1 comma 4 and 1 comma 9. So the x-axis is same. Okay, so they will like if this one is expanding in west direction and this one is expanding in east direction. Okay, no, sorry, this one is expanding in east direction, this one is expanding in west direction, the channel. Now difference between them is how much? It is 4, 9 minus 4, how much? It is 6. So obviously they will sorry, 9 minus 4 is 5, so 5 divided by 2, it is like, if you take seal that thing, that you will get 3 seconds. So minimum they will take 3 seconds to connect each other. So this is one case. So the edge weight for that these 2 points will be 3. Okay, now if like y axis is same, here we can see y 7 7 same, so the difference between x is how much? 8 and 2 6. uh, yeah, 8 and 2 6. So here also how much time will they take? Only 3 seconds. Okay, now if both the x and y are different, okay, so if a point is here and the other point is here, so now what? So now you have to like it will take the max of both the max of difference between them. So like 2 comma 6 is 6 minus 2 is 4, and 8 minus 5 is 3. Okay, so like to match their x coordinates, they will take 4 amount of time, and to match their y coordinates they will take 3 amount of time. Okay, 3 seconds. Obviously obviously when both the coordinates will match, then only we can like say that they overlap now. So yes, we have to take maximum of that. So at 4 seconds, like at 3 second, yes, their y coordinate will get matched, but after 4 second their x will also get matched. So total 4 seconds will be taken to connect them. So likewise we form edge in the graph, okay, of a particular. So I have just taken a graph, okay, of long thing. Okay, long edge weight it will store. So from like uh, graph of I comma j, I will write it here. Graph of I comma j uh, says the time required to connect I to j. Okay, yeah. So yeah, so what I will do, like if it is current, like the I will traverse from, like first loop is for the first I and the second loop is for j. So if it is same, the vertex is same, I will just continue. Else what I will do, yeah, now if the x axis is same, okay, no sorry, y axis is same, what I will do, uh, I will just do the thing which I have done here. Okay, I will just take mod. Okay, absolute of, sorry, mod, absolute, yeah. You will just uh, take absolute of difference between the y coordinates and divide it by 2. If it is odd, yeah, you have to increase it by 1, because in which happened in this case, because the difference was 5 and 5 is odd. So yeah, we have to take the maximum. So 5 divided by 2, we can't take 2, it will take 3 seconds, because 2.5 is not allowed. Not, we can't take in points. Yeah, in else case, if the x coordinates are equal, okay, okay, so this was for the x coordinates, okay, and this was for the y coordinates. So in this case was this case was for the x coordinates, and this is for y. If y are equal, then just we will take the difference of x coordinates, and yeah, we will put it here. Yeah, and one more thing I missed. Yeah, I have taken here input. Okay, so in the input you are given like first you were given like how much vertex are present, and you are then given every pair of vertex, like uh, coordinates, every coordinates. So array of I comma 0 is like x coordinate, array of I comma 1 is y coordinate for n vertices. Okay, now in the else case, where neither the x is equal, neither the y is equal, or both. So what you will do, you will just uh, make the difference, okay, of x coordinates, and the y, take the difference of y coordinates, and whichever is the maximum, that will the time required to store. Okay, time required to get into the, yes, get from I to j, to connect I to j. Okay, yes, yeah. So here we have made the graph. Now the question is, like you have to find like the minimum time at which all the wells are connected. So obviously now what we are doing, like if one vertex is connected to all other n vertex, likewise, so there are many edges in this. Okay, but we don't need now. If suppose like, okay, one there is one point, okay, this one is connected to 2, okay, and 2 is connected to 3, 2 is connected to 3. So we don't need to have an edge like which is like 1 is connected to 3. Why we need this? Because if 1 is connected to, then indirectly 1 is also connected to 3 also now. So we don't want this. So we want to minimize the edges, okay, but like how? So we want the minimum answer now, that and the edge should be minimum, edge should be minimum. So for that, what we'll do, we will remove all the edges which are maximum in length, and we will just keep only those edges which are sufficient enough to connect the graph indirectly, and we will remove all the others maximum edges. So this then convert into the maximum spanning tree problem. Okay, which is you are given a graph and you have to like find the minimum number of edges which are required on, sorry, minimum number of edge weights which are required to yeah, the edge weight should be minimum in that minimum spanning tree, and it is like sufficient to connect the whole graph. So the graph is connected, but all the edges which are not like, which are heavy or which are taking more time, we will remove all the edges, we will just keep the minimum edges, and the graph will be connected. So I have just called the find mst table, find mst, and yeah, after finding that mst in the graph, uh, the edge which would be maximum, that would be our answer, because yes, uh, all the wells will be connected in minimum time, like it's connected, like let's say some edge is connect, there is an edge, 4 3 4, then 2, then 7, then 5. So here 3, yes, obviously 3 seconds will be taken to connect one well to other well, then 4, then 2. Yeah, but total time, like we want to return the total time, so at max it will take 7 time now. So uh, yeah, before that all the wells will be get connected. So yes, we will, this function will return us the maximum edge weight from the mst. First it will construct the mst from this graph, okay, with n vertices, and then it will return the maximum edge weight from that mst. So I have taken that the template of like to construct mst. So okay, so this is the function for it. Yeah, find mst, and yeah, it is returning the long thing, okay, which is the maximum edge. Okay, so here you can see it is returning the maximum edge weight in the graph. Okay, I have initialized it here, and every point I am doing uh, maximizing, trying to maximize it. So here for it, they have used Kruskal's algorithm to find the mst. Okay, now let's submit it. Yeah, it's getting accepted. Okay, thank you all for watching the video.